This information, some of it was presented when PCAST voted on the report, but it was not nearly as in-depth a discussion as I hope that we'll have today. And not all of you are on the screen, which is awesome, or maybe you're on separate pages that I don't see, but please do just chime in with questions. The goal is to have a discussion here. So my name is Laura Campbell, and until recently, I was the Executive Director of the President's Council of Advisors on Science and Technology, which is a staff position, which meant that I had the honor of herding the cats who are the experts who serve on that council. So since the FDR administration, every president has had some sort of science advisory council, and this group was part of the President's Council of Advisors on Science and Technology for the Biden administration, Biden-Harris administration. And PCAST generally, of course, opines on topics that that administration cares about, but is not part of the policymaking activities of the administration and therefore has some freedom, especially later in the administration, to think about, well, what really are the kind of existential challenges that are facing the nation? Where can science and technology add value? And so this PCAST had already done some other reports relevant to climate change. They had one on the economic impacts of extreme weather, still relevant, understanding greenhouse gas emissions, perhaps not as much of a priority now. And then water was more of this big picture existential crisis. So I'm going to go ahead and introduce the members of the working group on groundwater, and then they'll each chime in later. So, the other thing is that since this PCAST no longer exists, they're still honored members of a former PCAST, but they're just speaking as private citizens, as am I. Um, so oops, I should advance the next slide. Oh, let's see if I'm smart enough to do that. Great. All right, so we have 5 members of the working group, not all of whom can be here today. You get 4 of them. So Joe Chiani regrets that he can't be here, and Laura Condon also regrets that she can't be here. She, however, is taking care of a brand new baby, so we all think that's awesome. Laura Condon is an external member of the working group who came on because of her deep, deep expertise in groundwater. So extra sad she can't be here today, but fortunately she taught us a lot before the working group wrapped up. So you'll hear from Inez Fung. So Inez is an atmospheric scientist, and she is globally recognized for her work on the carbon cycle, which, you know, is not the same as the water cycle, but still cyclic thinking, right? And she is an emeritus professor at UC Berkeley. Steve Pacala, also joining us, is an ecologist and environmental biologist who focuses on climate and ecosystem modeling, and he's now an emeritus professor at Princeton. We have Laura Green, who's a physicist and expert in quantum mechanics. That's why we were talking about quantum mechanics at the beginning of this session before we started recording. And she's known for her research on superconducting materials and high magnetic fields. And she has a side interest in the methods that we use to assess water quality. And that's one of the things that led her to join this working group, in addition to the fact that water is just very important. She is chief scientist of the National High Magnetic Field Lab and a professor at Florida State University. And Kathy Wotecki is also joining us. She's an expert in agriculture, food science, and nutrition. We had a great report on nutrition also. And she's a professor emeritus at Iowa State University, as well as a fellow of the Biocomplexity Institute at the University of Virginia. All right, so now I suspect that everyone who is here already knows about groundwater and what it is, but just for the sake of setting the stage and because, you know, we're recording and hopefully others will watch this, I did want to kick us off by talking about what is groundwater, all right? So groundwater is part of the cycle of water, the water cycle. So it is connected to surface water in many ways. And here we've highlighted in pink groundwater. It is the water that is below the surface of the ground, hence the name. And it is recharged by surface water. So when it rains over this lovely forest, some of that water seeps through. If there are lakes and streams, some of the water in the bottom seeps through. We can even facilitate recharge either by directly pumping water down into the subsurface or by putting big lakes that we then use for recharge. One thing to notice in this figure, however, is that some groundwater is more accessible to recharge than others. So this groundwater that's shown here, close to the surface, easily recharged, but the groundwater in these lower layers is separated in this diagram by thick layers of subsurface, thick layers of rock that water does not necessarily penetrate through. So the water way down here at the bottom is probably extremely old water. And when you pump it out, you don't get to have it again because it's very hard to recharge. I think that that's everything. Oh, and another thing to note here is that fresh water, if there's a lot of fresh water in an aquifer, it can flow out into the ocean, or when there's less fresh water, the ocean can flow into the aquifer. And that is generally called saltwater intrusion. And if you want to drink that water, you are less excited about it once it becomes salty. One thing to note is as we pump water out of an aquifer, it's not an underground river, it's a subsurface of gravel and sand, and some of the volume is taken up with water. As we remove that water, it's possible for the ground to compact, and that leads to subsidence. And these are some pretty famous pictures of the subsidence that's happened in the San Joaquin Valley, the Central Valley of California. And so, we've got about 30 feet of drop shown here, another 8.5 feet shown here between, not that many years. And then this picture on the left is actually a radar, data from radar images. And it shows in some places a 60-centimeter drop in basically 14 months' time. So pulling the water out does have dramatic effects. All right, so groundwater obviously really matters, as Inez has pointed out to me before. It's like a hidden gem that we rely on very much. So the blue in this figure on the right represents surface water, and then the orange is groundwater. And groundwater provides drinking water for about half of the US population, and irrigation consumes about 70% of the groundwater that we use in any given year. This water is embedded in almost everything that we eat, especially if we eat food from the Central Valley, right? And so groundwater is crucial to our food security, our economic security, and our very health and well-being, especially if you like spinach. So it's really, really important. And now I think I'm going to go ahead and pass it over to, oh no, I was going to keep talking through this slide. All right, so as I mentioned earlier, a lot of the water that we're consuming is actually called fossil water. It's very ancient water. And so this figure shows the cumulative groundwater depletion over about 100 years, a little more than from 1900 to 2008. And the red represents groundwater depletion of 150 to 400 cubic kilometers over that period of time. That's a lot of water. I know a lot of y'all, as ag people, think in acre feet. It's a lot of acre feet of water. And we see that the only places where we've had a net increase in groundwater is in this figure in the Pacific Northwest and a little bit in Idaho. So the water that we're now pumping out of the Ogallala is extremely ancient water. It's down deep, and we will not be recharging that water again, especially because of the sediment that overlays the Ogallala. And as we're going to add anything to that, or shall I just pass it on to you?
No, that's fine. That's fine.
Great.
So the groundwater that we use, there's also contaminants in the water, and there's natural contaminants because of the geology. There is arsenic and there is uranium and selenium, and from nitrate and other from pesticides, from fertilizers. They're nitrates, and what this figure shows is where they are. The sad thing, for arsenic is that the farmers in Central Valley cannot drink their water because who provide us our food cannot drink their water because of the arsenic. And the nitrate from fertilizers causes blue baby syndrome. So the clean water is very important, not just the drinking water, but the water that's available to farming communities. So what we were charged with is thinking about what the federal government can do. And the first thing to recognize is that apart from EPA that regulates water quality, the quality of our drinking water, safe drinking water, the federal government has limited role in the regulation and the management of groundwater. So I don't need to tell you that states and are primarily responsible for addressing the challenges and opportunities in their jurisdiction. And in some states, the British doctrine obtains, and so you own the water on your land, and other states is a common good. So there is no uniform regulation or protocol across the country. So the USGS coordinates the National Groundwater Monitoring Network. And so I just went through that data set. There are many wells on the register, but some wells only have one data point. Some wells have one data point per year, and other wells are very well will be have sensors that report in real time or daily. They have daily recorders. So the data quality varies across the entire network, and there's no calibration of saying, no comparison, no reference to say how do you do this, and how can I compare the differences from different measurements from different states. The USDA coordinates a census to gather data on irrigation and water management practices from farms and ranch operators, but the data may not be current. And for privacy reasons, we fully understand that not everyone is keen to share the data. So the Bureau of Reclamation, I don't need to go through, but there's Army Corps of Engineers, the Bureau of Reclamation. The bottom line is there is no central picture of what is going on with groundwater in the entire country. So can I so Texas is famed for overuse of water, and Arizona has active management areas, but mostly in urban areas and not in rural areas. And California, not just, but in the last decade, has the Sustainable the Sustainable Groundwater Management Act. And so this is not for individuals, but for water districts. And so then right now it's still in pilot state, and there's a lot of court processes when the authorities come to fine a district. There's a lot of pushback, and so this is still being worked out. But I just want to cite one successful example. Kansas is not the only one. I know Missouri has done this, but Kansas has the state management of groundwater, and so they're local, the LEMAs, the local enhanced management areas. So you can see here for different rainfall rates. This is without the management practice, and so this is the use of water with the management practice. So basically, Kansas says how much water your allocation for water for the next 5 years, use it as you will. And so here, whether you look at it, is the efficient use of groundwater per unit area or the whole total groundwater use. It's a very nice success story that management does work here. Steve, you're muted, Steve.
So we were at this, you can see, for the better part of a year at the end of the Biden administration. And having come into it with no groundwater experts on PCAST, we did, in fact, bring Laura Condon in, but we also felt it critical that we talk to everybody, and more so for this problem than for any other that I worked on while we were at PCAST. And it's because, the feds don't have jurisdictional authority here. And so the only thing we can really do is help the states and help municipalities and help private owners of various kinds. So I know it's a cliche that landowners are afraid when the federal government says they're here to help, but nonetheless, we still wanted to ask ourselves, how can we help? And to figure that out, we had to talk to as many different groups as possible. So we spent a lot of time doing this and talked to state managers, talked to regional managers, talked to tribal groups, talked to industry. We did a lot of this virtually, but we also ran a workshop in Phoenix with representatives of all the different stakeholder groups and stakeholders, and we also vetted various kinds of policy proposals so that we didn't want to come in as non-experts and do something that was damaging or dangerous or that would be resented. Okay. But we heard the same thing again and again and again, that groups from, ranging from, really, internationally recognized experts managing, California or Idaho's aquifers, all the way down to tribal groups, that they really had limited access to data and to models. This is the heroic age of groundwater modeling. We're finally getting an academic effort that is coupling surface and groundwaters in ways that are realistic and is dealing with the heterogeneity that exists at relatively fine scales, but implementing at national scales. And also, there is data, there are data sets all over the place in the federal government and in states, but it's very difficult to get one's hands on them. And when one does, it's very difficult, as Inez said, to rectify them, to make them comparable. So there were real limits to what people had access to in terms of data to figure out what was going on, and also into with respect to models to try to do some planning. Everybody, of course, said they were limited by available funds. I'm sure that's true, but that's a refrain that you hear no matter what, no matter what you're working on. All right. And also here, almost everyone commented on the lack of a skilled workforce in groundwater science management and especially stakeholder engagement. All right. So this is an area where people are justifiably and concerned about their livelihoods and livelihoods that their families sometimes have pursued for a century or more. And so this really is a case where the science needs to be explained in a way that a local community can understand. Next slide.
Before I move into the recommendations, do any of our other participants have something that they want to say, some questions, anything like that? Just encouraging you to speak up. Go ahead, Steve.
Okay, so we asked ourselves, how can the federal government help state and local water managers? What research is needed to safeguard water security and sustainability in the future? In other words, could the federal government fund some research that would make everyone's job easier? And what are the potential incentives that the federal government can provide to promote sustainable water use? And so there, the states are like an experiment of different water management practices. And so some are in line with current science and some aren't. And at least in principle, the federal government could reward efforts that were aligned with current science and technology. Next slide. So we had a series of recommendations. And the first is an Uber recommendation, and that is that it's time to provide a central resource, which is a data repository and a repository of tools. The tools are analytic tools, how to analyze data, but also predictive tools, groundwater models that are sort of state of the art. And we recommend that this repository of data and tools be under the guidance of an interagency group on groundwater security and sustainability. And this recommendation was divided into a bunch of sub-recommendations. So let's jump to those. Laura, next slide. So the first one is that this interagency group should designate the USGS as the lead agency to host the federal groundwater data, the inventory data, and to ensure that common protocols link it. Now, again, participation in this at the federal level is voluntary. You can't go to a tribal group or anybody else and say, hand over your data, right? But nonetheless, there is a lot of federal data that taxpayers have already paid for, some of it accessible, some of not, and others would be willing to contribute their data to a credible repository. 1.2 is to develop tools to enhance the use of this information. And that's a national framework to coordinate hydrologic modeling. We've seen this sort of thing in the sciences again and again and again. The academy, when all of a sudden an effort is possible, it's possible all of a sudden to model something in the way that you'd like to, which is, I think, the case here, right? Where if you just leave it to the academy, all kinds of legacy codes hang around and there's, all kinds of heterogeneity, it's not coordinated. And so it's really helpful if in fact there's a central effort, not directed by the federal government, directed by oftentimes the researchers and the implementers, but in which, for which, models are skill scored and you can make some sense of them, because otherwise it just shortens the process from something that's academically useful to something that's practically useful by more than a decade, right? And we need these tools now. Next
I'm
slide.
just going to chime in on that idea of skill scoring. So on the one hand, when we think about data, you could say, well, there are academic groups that are already building some models. There are private sector groups that would love to make bank from having a model and selling it. But what we've seen in climate modeling is that, for instance, insurance providers are using climate models that predict risk of, whatever. And some of those models are good, and some of them are really bunk. And it's hard for the user to understand which models are good and which are not. And this is a role for some group of esteemed experts to weigh in and say, here are the standards in order for your model to meet the criteria for its data to be incorporated, like we do in weather data, right? Like when you get weather data from the European weather model, we've skill scored that model. We know when its predictions are effective and when they are less so. And that's a coordinated effort to get better data rather than just letting it all be kind of the Wild West.
Yeah, there's no shortage of private sector providers of information. Like, for instance, in hydrology, not groundwater, but flood risk. There are all kinds of groups that will sell you flood risk projections now, but none of them have been skill scored. All right, and it's possible to skill score them now. So anyway,
So let me just add that on the modeling side, the climate models, the upcoming climate models are really doing much better job on the prediction of I wouldn't use the word prediction, of the projection of precipitation. And this is using, Steve, we talked about this, the next generation, we were going to not super high resolution, but say 10-kilometer resolution, but we're going to run 100 ensemble members so that you can get the statistics, you can get the extreme, etc., etc., etc. And so that those projections, I think we talked last time, those projections, we can't tell you because how accurate those projections will be, because we don't know what the CO2 levels, what the methane levels would be, what the forcing might be, but it gives us an uncertainty estimate. given that I'm going to give you what the probability of an extreme event might be, we will be able to generate that in the next 5 years.
Okay, so next slide, please. So the second set of recommendations are about future research, expanding the existing toolkit, right, to do more, expanding the kinds of data that are available. And this is divided into two pieces. The first one here, which is 2.1, takes advantage of the fact that it's now possible to fingerprint water samples with measurements of levels of hundreds of thousands of chemical species. All right. And so, I mean, this is an amazing development that has the potential to be scary for landowners. I don't know how well this recommendation would fare in the current administration, but if a state really wants to know where its groundwater is going and what's in it, it's possible to know now. And a company might have the resources to do this and provide the data to the private sector. Most private sector, a lot of them won't want to know. But anyway, we can talk about this recommendation has a very different backdrop than it did during the Biden administration. Next slide, please.
Laura, do you want to chime in first?
Yeah, I just want to say that it's a technique for analyzing very complex fluids where you get the mass resolution down to the mass of an electron. And it's a complex analysis, but it's used for petroleum and all kinds of other areas. It's also being developed more and more in groundwater for a couple of reasons. When Inez talked about some of the arsenic and the nitrates that are higher and higher concentration as we mine older and older fossilized groundwater, the existing concentrations of impurities get higher and higher. But also what Steve was, I'm just echoing what he's saying, we're putting hundreds and hundreds of thousands of chemicals into the groundwater now that didn't exist 50 years ago. And we know how to test it, but EPA doesn't know how to test it. So if we just have this as and I like the way Steve put it, as a research direction, so at least small people will collect data if we need it later. I think it's very important. I'll point out one other thing is that by looking at what is in the pollution, or any kind of pollution, you can tell if you're going to get an aquatic bloom or not. You can tell if it's going to get much worse in 5 years, or it's going to be pretty quiet for the next several years. So there's a lot of reasons to do this just for the research aspect and to train students in these interesting techniques.
So the second bullet under recommendation 2 is to focus on recharge and delivery, to expand the pool of groundwater that is usable sustainably. All right. And so we think there should be a national initiative on managed aquifer recharge, and that the federal government could help with convening and so on. But we also think we need research on other ways to enhance recharge and also to deliver water to replenish aquifers, perhaps through long distance transport. There have been some that have promoted this. I personally am skeptical, but maybe you could get the energy costs down low enough. Cheap desalination and so on. And 2.3 here is to support research in the agriculture and land use sector that would allow landowners economic alternatives that are consistent with groundwater availability. And so you can imagine that additional feedstocks, for instance, for biomolecules that are promoted by agricultural research within the federal government, could be coupled to the need to actually have a sustainable groundwater use in areas where aquifers are being depleted. Next slide, please.
Kathy, were you going to chime in?
Oh yeah, Kathy.
Sure, I'd be happy to. Inez mentioned in her opening comments that the National Agricultural Statistics Service and the Economic Research Service at USDA collect data from farmers and ranchers about their current practices that are really important, uh, along with the economics of our our farmers that are very important data as well. And in addition to that, the Department of Agriculture has for historically sponsored groundwater research in that falls into really two big buckets. The first is research and development that's directly related to understanding the effects of agricultural production practices on groundwater. And the second bucket is understanding how different changes can be made to agricultural production practices to reduce water required in production that in turn would reduce the demand for groundwater and prolong groundwater availability for all of us into the future. These research programs have had a major focus on areas where irrigation is very prominent. And also in the introductory comments, it was briefly mentioned that agriculture accounts for 70% of groundwater use. But this research is not exclusively related to those areas of the country where irrigation is prominent in agricultural production systems. The USDA research also recognizes the regional nature of aquifers and the need for regionally appropriate strategies, leading to regionally appropriate solutions. So the research is done both intramurally in the Agricultural Research Service as well as Forest Service labs and at universities through grants that are provided. With the delivery of the results from both of these research programs to farmers through cooperative extension programs that are administered through the land-grant universities in each state, and by programs that are administered by NRCS. And just to give you a couple of examples from both the intramural and the extramural programs, from the ARS labs, they've had a major focus on understanding the effects of agricultural systems on groundwater and the development and management practices to improve groundwater quality and quantity or recharge. One big result of their program has been one of these models that we've been talking about. It goes by the acronym GLEAMS, the groundwater loading effects of agricultural management systems. And it's a field scale model to evaluate the impact of management practices on potential pesticide as well as nutrient leaching at the root zone level and below. And it's a tool for assessing the effects of farm management decisions on water quality. The extramural programs, the grants that are funded at universities, one recent example has come from their Water for Agriculture Challenge grants that are administered by the National Institute of Food and Agriculture. These tend to be longer term, larger grants, like 5 years in length, about $10 million over that period of time. And one of these major grants has gone to the 8 states that stride the Ogallala Aquifer, primarily to coordinate the water research and the management strategies and outreach that's coming out of that research. So that there's a good set of recommendations, coordinated set of recommendations that are going to producers based on the research that's coming out of that. So together, the data systems that we talked about and the research that's coming from the intramural and the extramural labs goes to inform then the programs directed towards producers to help them better manage this water resource. And those are largely administered through NRCS, and to a certain extent also through the Forest Service. So all of these programmatic areas, though, in the recommendations that Steve just went through for you, would also greatly benefit from the interdigitating of them, making them more accessible through the kinds of recommendations that we made, so that others could have greater access to this underlying research and data that's being generated. So that's just a snapshot into what USDA's programs are. And as we referred to at the beginning, we think that this is a major issue and one of continuing importance to the country and to the long-term welfare of agriculture, and something that we hope is going to be continued and that these recommendations will be acted on. So I'll turn it back over to you, Steve.
Great. I'm going to also pick up the pace here so that we can get to a general discussion within the next 5 minutes. So we recommend the establishment of a network of groundwater engagement hubs. We heard again and again from local groups that they lacked the capacity to evaluate the alternatives that exist for managing their groundwater, to understand what their groundwater is doing, and so on. We heard this from tribal groups also. And so we think it's time for the federal government to have a network of extension service like hubs that would provide people that actually go to local meetings, but also serve as a repository of technical expertise to show people how to use the data that exist, how to use the models that exist, and to advise them on which were the most appropriate methods and models. Next slide. This one is one that might be more controversial now, but it's something that we strongly believed in. If you still do, if you look across the federal government, there are quite a number of incentive programs that are aimed at non-federal and at federal water managers, groundwater managers. And these are well-intentioned, and a lot of them are really valuable, but they do lack critical mass in any one place. So that, for instance, if you have an area where the state, for instance, really wants to enhance recharge at a scale that matters, it's very difficult to corral enough federal funding to do that, even though the federal funding to get to scale may exist collectively. And so what we recommend is, in the absence of large-scale increases in federal funding, which are unlikely to be forthcoming, that the executive branch organizes what funding exists into a competitive grants program where managers can come together and apply, and if you're selected, you have access to a sustained piece of funding that allows you to make a transformative change. And this also will allow the nation to increase its pace of learning by doing at scale. Next slide. During the Biden administration, there was an expansion of valuation tools and evaluations to try to be able to incorporate traditionally non-monetized benefits in cost-benefit analyses. And this includes evaluation of groundwater resources and natural capital accounting. And so there were recommendations that were made. This was done outside of PCAST. It was organized, I think, within OSTP. And PCAST fully endorsed and still, well, I think the members here all endorse this effort. Next slide.
Sorry there, if I could just go back to that last recommendation there.
Sure.
From my point of view, I mean, this is happening as we speak. You just need to look at the value of land. The people know in the local areas how much a land is worth, in areas at least where groundwater irrigation is critical, and when there's no surface water options available, particularly in Texas, Kansas, Nebraska, parts of Wyoming. I think it's great to try to value the natural capital, but you can simply look at sales prices, and that will tell you how much water there is or isn't.
You're absolutely right. The information exists, and the people who put this together for the White House are real experts at looking at exactly the kind of data that you just described and turning it into a shadow price that can be used in cost-benefit analyses. And so, right now, for instance, the federal government makes decisions on land that it does control, on public lands, without valuing the groundwater resources in a way that's consistent with the way they evaluate other things. And so this shadow price mechanism is one that sort of allows that kind of valuation to permeate other kinds of deals in society, other than those that are focused on, for instance, how irrigatable a piece of land is that they might want to purchase or sell.
And Court, this was most relevant to the way the federal government does its own internal natural capital accounting. So should we use this land for grazing, or should it be used for timber growing? Actually, those are like not compatible uses at all, but like basically to what use should we put public lands, and just folding in the cost and value of the water resources as part of that. And it is a bit controversial because the less background information you put into how you value the public lands, the lower the value, and the easier it is to say, oh, you should just let the farmers graze all over that, or whatever. And the idea was just that we should think about what the overall value of the resource is and its longer term sustainability.
Would be. So I don't know exactly how you would equate that if you take it out of private sales, but I mean, I think that would be wonderful, particularly the farther west you go, because the current evaluation of BLM and Forest Service lands, generally, as we're talking about agriculture, strictly around grazing. Many of those lands are arid and there's not a lot of groundwater, but there might be, and the nature of the aquifer doesn't respect those property lines. So, I mean, if you could fold that into the analysis, you'll get some pushback from some folks out there used to grazing on pennies an acre, but that doesn't make them right. We're talking about a natural resource of this magnitude.
Yeah, I want to emphasize this effort is ongoing, even though the 80% of the people who was part of that team, as TP, are not federal employees, so they are continuing the work. So we look forward to how they choose to prioritize and how the methodology is used.
Great. Next slide. And I think this is the final recommendation. And this is just, we need a comprehensive campaign to recruit, develop, and retain a skilled workforce in groundwater science management and stakeholder engagement. And this could range from federal funds to entice undergraduates and graduate students into work in this area, and other programs to make sure that we have a skilled workforce, because we heard again and again and again that there is a shortage of people. Even if you had the funding, you wouldn't be able to hire the people to do it. Next slide. Okay, so this is just a summary that our recommendations are aimed at helping state and local groundwater managers and users, and also Mom and Apple Pie statement that, we really do need science-based management of groundwater. I think everybody here on the call believes that. So I think we should turn this over now to just a general discussion.
That was outstanding. I really do appreciate the breadth of what you've covered here, as well as diving deep into a few holes. And there's several things that I'm very interested in, but I'm going to go back to the chat box here. And Peter, you asked a wonderful question, and I'm going to invite you to turn your microphone on and state that in a way. I love the philosophy behind the question.
In terms of cyber physical systems, which PCAST had another report on, water is a particularly frail part of our cyber physical world. And the cyber physical idea is that, like, sure, we think about cybersecurity, but every single physical thing in our world is controlled by a computer, literally everything. So the water that I get out of my tap, it's controlled, by all of these systems that control what goes in to purify the water, where it's pumped from, how fast it's pumped. And especially in rural areas, those are small water systems. They usually have one guy or girl doing 15 different things, and only one of the hats that she wears is related to maintaining the cyber the cyber resilience of their control systems. And the points that you make are really good, and especially for those communities that are particularly dependent on groundwater, it is a frailty.
Yeah, my only commentary really quickly on that is I've found that our most effective outcomes happen when the scientists like you all get in a room with people like us who banter back and forth and poke on these ideas and contemplate, like, really
I can tell you that during the discussions about the cyber physical resilience, the scientists in the room, which were almost everybody, were just shocked that the technology experts said, we're going to have a backup manually controlled infrastructure in the United States that maintains certain minimal services. That's the
Amen.
only way we can protect ourselves in the end.
Amen.
We need to actually start now with a generation's worth of work to build that. And that goes, water is a central part of that. One other little tidbit about groundwater is that, everybody says we need more reservoir capacity, we need more storage, not just because of the issue you raised, but also the climate vulnerability as the climate becomes droughtier. And one of the really interesting things is that if you look at the refillable capacity of subsurface aquifers, it rivals our total capacity for storing water in surface aquifers. And so when you say we don't actually have the ability to make more reservoirs on the surface, no, but we have we have a whole bunch of reservoirs that we're just not using in the subsurface. That's
and can we agree that that would require a bunch of control systems to be pumping water in and out of them as needed, right?
Yep.
I just want to thank Peter for bringing that up because, being a physicist, I think one of the failings we've had is that our policymakers, scientists, and military have not had good conversations. And that's why I was writing the on PCAST. And I don't know how to follow this up, but I could not agree with your point more. So thank you for bringing that up.
Thanks much.
Robert, I think you had your hand up.
Yeah, I have a question here that I was able to attend with my lovely wife last March, a year ago, the Ogalla Summit out in Liberal, Kansas. And it's the first time I've been invited to a scientific summit, so to speak. And I was shocked at the ignorance of the problem. And maybe it's me that's ignorant. I want to throw this out and get some feedback. But the problem that is stated by the scientist I was sitting at the table that I was sitting, there were some 200 or 400 people there, most of them scientists, said that they have been tasked the last 20 years on how to reduce the flow out of the aquifer. Right? And I said, well, is that the problem? Is there enough water on the earth for us? Yes, there's plenty of water. The problem is it's not where we need it, right? Okay. So if you were tasked with just reducing the flow of the Ogalla aquifer, now you're giving me dates in which it'll die, right? well, why don't you give me a date in which we'll have more water and we can sell it to Colorado because they're idiots and they'll buy it anyway. So the setback was, well, where is there other water?
Yeah, so this is one of our, yeah, one of our,
let me go on, please. So is water in the topsoil considered part of the aquifer?
Generally, water that's in the topsoil is not considered part of the aquifer. It's considered soil moisture.
Right. And how much soil moisture have we lost since humans started farming this ground? No, how much? When Lewis and Clark came across here, what was the SOM in the state of Kansas and the southern boundaries and the northern boundaries?
That was some very effectively water retaining soil because of all of the natural grasses that were living on it. When it rained, that water was held.
Yes, but it wasn't held because the grass is on it. It was held because of the carbon in the soil. Is that not true?
Well,
Okay.
yeah, but then we
So
took it off the top and it blew away.
Yeah, so the SON was 12 and up in the northern parts of Kansas and 6 and below in the southern parts, right? If you take 20% of the ground in Kansas, farm ground, 47 million acres, average it out to 10 million acres and you raise it back up to 12, are you going to fill the aquifer back up? Yes, you are. Yes, you are, over and over and over and over again. And I sent a little thing that a bunch of scientists did on the math on that around. And I think we're missing the whole point here is where can we get the water to displace what we're using and at the same time lower the ocean levels because we're going to flood everything on the outside if we don't do that, right? Where was it before us humans got on board here in such big quantities? We stored it in the topsoil. It's still there. It's going to be there when we're dead and gone. Our species is gone. Why don't we work with her, nature, bring those topsoils back up so we don't have to pump as much water out of the Ogala aquifer to grow our corn or whatever the hell we're going to grow next? And make it a simple problem that science really can affect dramatically. But it requires some logic to it as well. And that to me is what I saw missing was logic. And Jimmy and Emmons and I argued a lot about it at that conference. He was there, and so was the head of the ag department. And they're missing the point. There's plenty of water. You just got to go put it where you can get to it.
Well, so let's just be clear. First of all, you're preaching to the choir that about restoring the carbon backbone in our soils, and also the possibility of going to more perennial cover in some cases, because the rooting zone does help. The rhizosphere helps some.
Without a doubt.
Yeah, and there's no doubt that it doesn't just help with the greenhouse gas balance. It also helps store water, and it also helps with nitrogen and nutrient delivery, right? So it's a triple win, and we're all for rebuilding the carbon backbone of soils. I personally like biochar. Not everybody does, but and so on, right? However,
I don't like biochar whatsoever.
I know. Okay, I don't want to argue about that. However, I do want to say though that if you look at evapotranspiration alone,
right,
and you look at the changes in the climate, in lots of places, there's a mismatch. And the mismatch is not just in some years. So when you say there's enough water in the soil or it could be put there, that's sort of true, but sort of not true. And if you want to enhance storage, you've got to go beneath the soil as well. If you want to bring water in from another place, we've got a real problem with expense. And so we actually need research to improve that. You can calculate that to move water for irrigated agriculture without the price blowing out through the roof, you need energy at something like 1 cent a kilowatt hour.
Yeah,
Be able to move it.
ridiculous.
It's really tough to do. So
Yeah.
I think that I agree with what you're saying, but it doesn't obviate the problem.
Well, it does obviate the problem if we begin action to alleviate the problem. And us sitting here in a circle jerk doesn't get it done. And
I
that's
agree
what's
with that.
happened in the last 20 years in science, as far as I'm concerned.
Yeah, well, I agree. It is time to get to take action. I agree. And
my
restoring the
being
carbon back to
calls
the
me
soil,
once a month. The
great thing to do.
Secretary of Ag calls once a month and says, what can we do to help the state of Kansas? I said, store more water in the topsoil.
And
Inez,
Inez,
what are you gonna
Yeah,
Inez
that's a
had something to
novel
offer.
idea. That's
Rob,
enough.
I think Inez has a question.
I just want
Okay.
to, no, I just want to add that in the Inflation Reduction Act, there's a healthy soil initiative to the USDA. So they're working on it. So we're not ignoring the problem. Okay, so but we hope progress is not stopped in that direction.
Well, the progress hasn't started, and Mike Beam calls me once a month. That's the Secretary of Ag for the state of Kansas. Wants to know what's going on with water nationwide. And I tell him the same thing that's gone on the last 20 years, not a goddamn thing. They're talking about it and pouring money into universities for research scientists so they can have a budget and make a living, but they're not solving the damn problem. And the easy way to solve the problem is begin storing water where you took it out from. And that was the topsoil.
So I'm aware of some soil refurbishment initiatives. I know at least one challenge with that is getting the farmers to actually buy in to doing something different. But I wonder, Kathy, you've got to know more about these efforts than the rest of us, or many
Yeah,
of us.
that's a really good point. We're down on hundreds of thousands of acres now, raising the carbon base in those acres and the storage quantity for water. But we've got to be down on millions of acres and make a difference. And your help here is desperately needed. We need to scare the shit out of these people and said, oh, we can squeeze this water down for another 25 years. So my son has to worry about it. I don't. Is bullcrap. Scare the hell out of them. We're going to lose the water next month. And by God, we got to start doing things immediately in order to survive. And if we don't do that, we're going to piddle away again.
Well, Rob, you recognize that this is one of my calls that I convene, and I'm the guy that goes after existential problems. So, if there's any team out there that's going to be able to carry this forward, they're on the call right now, and they're our friends as well.
I am here to help any way I can with anybody. So we got to make this world a better place for our kids. My son committed suicide, and he was working in the carbon space as well. The only thing that he told me before he left was, stay the course, Dad.
Well, I think Rob's really summarized what we all need to do, and it's a call to action. This is an important issue.
Yes.
And as we've talked about, there are different ways to go about finding the solutions, but we need action across the board on those solutions.
And I am offering my services to call people out and to make myself a target to help that action begin to take place. Whatever I can do, please let me know.
Thank you.
Appreciate that, Rob. Well, and in terms of taking some action, John, I don't know if you want to chat a little bit. I did put a clip of his video from the presentation he did in 2023 at one of the, I follow the NIDIS, the drought seminars on NOAA, and he gave a really nice presentation on the aquifer recharging efforts in California, which I thought it was genius. And if you watch the video, I think you'll agree with me as well. John, do you want to chime in a little bit on some of the work going on for recharging these aquifers?
Yeah, you guys hear me?
Yep.
Let's see if my camera works too. Yeah, awesome. Yeah, so I guess the background, I think everyone's probably familiar, but right now in California we have legislation called SIGMA, which is essentially, I don't know, it's kind of it's basically a law that was passed in 2014 that basically says that all groundwater basins in California need to come up with a plan by 2022 if you're a groundwater basin that has historical issues. They basically quantified all the basins either as medium or high priority, and if you are fall under that classification by 2022, you had to come up with a plan to achieve sustainability. And sustainability was defined with like 6 different criteria. Kind of the important ones, at least in the Central Valley, are to stop land subsidence and also to stop groundwater level declines. And essentially right now, about half of those plans in the Central Valley have been approved, and then the other half are they call them insufficient, or essentially they're iterating back and forth with the state to make changes. And actually what we're doing right now at the USGS is we the state, as they review these plans, has put together a giant database of every single recharge project that is proposed in these plans. And we're actually trying to put together simulation scenarios where we're projecting into the future and seeing what the benefit is going to be of basically these projects on a statewide level, because a lot of these, as part of the plan to achieve sustainability, each of these individual agencies submits it's called the GSP, a groundwater sustainability plan, and usually in those plans they have like at least the local scale what the benefits are going to be, but we're kind of interested in what the cumulative benefits going to be across the whole Central Valley. So that's at least what I'm working on right now at the USGS. And we have a future conditions run that we're putting together that has a few different versions based on future land use assumptions and future climate assumptions, and then for each of those different scenarios that have different inputs, we're gonna essentially simulate these MAR projects and see what the benefit is. And I know at the very beginning of the talk we were talking a little bit about what aquifer you recharge the water in is really important, upper aquifer versus lower aquifer. And that's one thing we've definitely found, at least for the subsidence portion, is that you do the surface spreading, but only about 3% of that water ends up getting down to the lower corcoran layer, or below the clay layer, where a lot of the pumping and the subsidence is actually taking place. So a lot of these plans to do like more indirect recharge, like where you deliver more surface water and stop pumping those deeper wells, those are actually the projects that seem like they're going to have the most benefit from some of the pilot simulation runs that we've done. So that's kind of where we're at least the work that I'm working on.
Well, I appreciate you joining us. I know it was kind of out of the blue, me following you there and saying, hey, I think your voice would need to be heard here. And then one voice I do want to hear is Court's. I mean, Court, you were the man that started this whole thing in motion. What questions, comments, suggestions, or observations do you have?
Well, I just might, my overarching comment is one I had earlier is, this idea of creating a hub, I think sounds very good, but local conditions vary so tremendously. And even within small regions, I just don't know how realistic a goal that is to get everybody to come to the table. And then maybe it would be great, but I just don't, I'm just thinking of the small region that I'm most familiar with. And I would posit, it always astonishes me to hear from California, how far behind the curve California is in managing its water resources. And I think there's been political reasons for that based on what I understand. I'm not super familiar with California, and it's not often that you hear the words state of Nebraska and progressive put in the same sentence, but the state of Nebraska has done an amazing job of doing its groundwater for 40 years now. Right north of Kansas, there are places where there are farmers complaining that there's too much water because it's coming out of the sandhills and taking away their acreage. So, if you're looking for a place to study that is local and has dozens of natural resource districts, which is how they do it in the state of Nebraska, that are successfully implementing on a local level. And I think I learned on this call, there's some geological reasons why it's favorable in Nebraska for that. So Nebraska, the first time in its history, has some built-in advantages. Wow. Also, I would but that's an area where it's being managed extraordinarily well, and in direct concert with surface water for irrigation as well. And so I'm happy. I know half a dozen water managers out there, and maybe even of more import, farmers, except for in a certain area where the aquifer is declining. For the most part, the aquifer is doing very well in that part of the country, and that might be a place to study for a best model. Again, our friends in California continually astonish me with how they're just now and I can't imagine it's just now beginning to occur. I think there's been reasons for that, but it may be in a place like Nebraska, particularly Western Nebraska, where there's been less at stake. The real estate is less valuable. There aren't three gigantic metropolises also jockeying for position. You have more of a pure, if you will, a pure experiment around what can be done around groundwater. You also, that water is flowing east to the Mississippi. 200 miles east of where I'm thinking they have floods. So you're right in this kind of special area where it's almost like a pure lab because the water has gone pure. There's no development pressure and it's gone purely to agriculture with a tiny bit of industrial thrown in. So maybe, and I'm sure it's come up in your studies, but this is maybe a way to look at it. Just a pitch for my homeland, I guess. Also, and thank you for having me here.
We definitely talked to the groups managing the Northern Ogallala and Nebraska in particular, and are aware of the enhanced groundwater resources in some places in direct contrast to the rest of the aquifer that it is loosely connected to further south. So that's one of the success stories. And it's one of the reasons we thought, gee, if you had some coordinated action focused on an individual place, you might start to see those success stories multiply and get a lot of voluntary buy-in, that when you're enhancing a resource for everybody, it's a very different picture than when you're circling the wagons and it's contracting down again.
I mean, and in that area, I'll try this my last comment. You've had the stick and the carrot. The stick's been, look at our friends to the south, right? This is what's going to happen in Texas, in Oklahoma, and Kansas. And the carrot has, and they capped, for instance, you can't drill groundwater, you can't drill wells anymore in the state of Nebraska, irrigation wells. It's remarkable. So there's your stick. Your carrot is, hey, we got water, and everyone kind of understands, and it developed organically over time. And I just feel like, anyhow, I'm not sure how you implement it in places where things are already far gone and what you do. I don't know how exactly you solve that, but the solution is out there, I feel, and it's reflected, and I think will be reflected on the market and land values.
I think that's exactly it, Court. That's going to be where it really comes home, because there's a lot of short-term thinking going on where it's just thinking about the next crop or the next 5 years worth of crops, and there's no need to change because the water will be there that long. But as you think further and further out, that need for sustainability for the economy of the state or the region is really important, plus your own individual thing. One thing I was going to say, thanks to John for joining us, is that I was reading that part of the Sigma plans, or the plans instituted under the Sigma law in California, is that, a water management district can fine people who pump beyond the level that was agreed to. And of course, then there's litigation. But the decision that intrigued me was that whichever court the first of these things came in front of said, you pay the fine while the litigation is ongoing. So making it so the litigation isn't just a way to cover your behind and keep doing whatever you were doing is potentially good news. On the other hand, having it all fall down into litigation is never the best outcome. Like, we need to just do the right thing.
Excellent. Well, we've gone over time a little bit, and I appreciate everyone who's stuck around for this, because I could listen here for another hour. But Dr. Campbell, your team, thank you so much for this wonderful presentation. This is a topic that will not go away. I promise you will hear more about this, and you'll be glad you listened to this webinar. So thank you very much.
Thank you. Bye.